A little problem, exercise 2.7 in Smith, and we're told from the question that we've got some soil which is overlying an aquifer. There's 3 different soils, 1 meters, 2 meters and 3 meters thick, and they're sitting on top of this aquifer down here. Soil A, soil B and soil C, and we're given them information about their permeability, and the question asks us is to work out the permeability in the soil, or the combined permeability in both the sort of X direction and also in the Z direction, and we're given the permeabilities of each of these soils, K1 or Ka, Kb and Kc, and we're going to combine those together. And the simple way of doing this is to look at the equations that are given in Smith's book, and they are on page, just getting my notes out here, they are on page 79, and from this we can see that the KZ, pen's it not very bright, is it? KZ, well, let's do Kx first of all. Kx is equal to, he puts down H1 K1 plus H2 K2 plus H3 K3, and all of those are divided by the total thickness of strata. So that's the equation that's being used for Kz, and basically each of these refer to the different soil types. So in our case, H1, we could perhaps call this soil A. Okay, we're told that that's 1 meter thick. K1, from the question, we're told what that is. We'll go back to that now. 3 times 10 to the minus 1 millimeters. 3 times 10 to the minus 1 millimeters per second, and so on. And so this follows through each of these different numbers you can put in, and I won't do it for time. Each of you can do those things, and H3 and K3, and fill in the blanks really. And H is made up of H1 plus H2 plus H3, which again we can fill in the blanks, and with all those parameters we can just feed those in, and then that will tell us what Kx is. For the second part, we're trying to find what is Kz. So this is the permeability through the soil, as the water from the aquifer would tend to find its way up through the soil. Kz. Again, we can go to Smith's book, and the formula for Kz is given to us again as Kz is equal to H, and this time this is all divided by, this is where we're adding these up now in parallel rather than in series, over K1 plus H2 over K2 plus H3 over K3, and so you can see again the numbers we've all had from before. We can find what Kz is. The actual question asks us to find the ratio of Kz to Kx. What's the ratio of those two? And that's quite simply found from the average permeabilities in the horizontal and vertical directions. So the ratio, we're asked the ratio of Kx over Kz, and we should be able to get the answer. Okay, so that's the first part of the question. So I would leave you now to fill in those blanks, and hopefully you'll come up with the same answers as what Smith does.